Hello students, this is the help video for the Physics Unit 5, 4 through 5 exam, questions 12 through 20. All right, so taking a look at question number 12, some background information that you need to remember is that there are 4 ways in which we learned how light can interact with matter. The first is transmission, where the light just goes through the matter without changing. You can see an example of that right there. That's how you can see through things like air or glass. Absorption is when a light ray gets absorbed and gets converted to a different type of energy. Generally, that type of energy is heat. And so there we go, heat. And you can see an example of that right here. It's just going into the substance and actually staying in that substance, changing into heat. So for example, that's why air warms up when it absorbs light. Reflection is when the light ray bounces off. So you can see an example of reflection here. It's bouncing back towards where it came from. Again, anytime you have this idea of bouncing straight back or bouncing back, that is going to be reflection. And finally, refraction is when light actually bends. So the light does go through the substance, but then bends as it goes through the substance. So this is important to understand. Reflection, again, bounces back completely, whereas refraction, it's going through the matter, it's just bending. Okay, so let's go ahead and take a look at question number 12 again. So this one is taking a look at what's happening to different colors. And so we learned that color is the result of what is being reflected. So for example, you can see right here that for this red ball, this red ray right here is being reflected. And so that is why the red ball appears to be red, because it's reflecting red light. Okay, every other color it does absorb. So you can see right here it absorbs orange, yellow, green, blue, violet. Okay, so we want to see which ball reflects the most light here. So the most light here is going to be reflected by the white ball. We can see that all of these light rays are actually bouncing off. Right, so let's go ahead and type that here. Right, so the white ball, and as a result, if you are wearing a white shirt in wintertime, for example, then this ball or a white shirt would stay much cooler because all of the light is being bounced off. It is not going into the object, and so therefore it helps keep you cool. On the other hand, which ball is absorbing the most light? Well, we can see here that the reason black balls appear black is because they don't bounce off any light. There is no reflection. So instead of reflecting all the light like the white ball did, this time it actually absorbs all of the light. And again, we learned just a moment ago that absorption creates heat, right? So the one that's absorbing the most is the black ball, and in this case, absorption creates heat. Absorption creates heat, and so therefore this black ball gets much hotter. So if you wear black in the summertime, then you will get much warmer. So the same concept can be applied to question number 12. Pause the video and then continue playing when you are ready. All right, so let's go ahead and take a look at question number 13, opaque objects. The reason that they appear a color is because they are actually reflecting that color. So remember, the reason objects appear the way that they do, the color that they do, is because that color is being reflected. So if we're taking a look just like on the previous slides where we saw light rays coming in, then we know that whatever color gets reflected is the color the object appears. Whatever color light ray gets reflected is the color that you see. All right, so that should help you with question number 13. Pause the video and then continue playing when you're ready. All right, so now let's go ahead and talk about questions 14 and 15. Questions 14 and 15 are very similar. Question number 14 is asking about electric charges, and question number 15 is asking about magnetic poles. But again, they do act very similarly, so the same concepts apply. So when we're talking about charges, remember that we can either have positive charges or negative charges. And so depending on how those match up together, they will either attract or repel. So remember that like charges always repel, so that means if we have two charges that are the same charge, then they are going to repel, whereas if they are opposite charges, meaning different charges, so a positive, negative, or you could have the reverse, negative and a positive, then in those cases, those would attract. The same thing is also true with magnetic poles, just now talking about the different poles, right? There's north poles and south poles. Again, like poles would repel, so if they had like, meaning they have the same poles. And again, opposite poles would attract. Again, that's going to be talking about different poles, right? So if you have a north with a south, or vice versa, a south with a north. All right, go ahead and work on questions 14 and 15, and then continue playing when you're ready. All right, question number 16 talks about a bunch of different types of energy that we discussed in class and applies it to different scenarios, including a motor being the most recent example that we took a look at in class. So remember, we talked about chemical energy. Chemical energy is the energy stored in a substance. So this could include things like batteries or food, both of which are made up of chemicals, and once those get used, they release energy. So battery chemicals release energy, or for example, food chemicals give your body energy. Mechanical energy, there were two different types of mechanical energy we learned about. We learned about kinetic energy. Energy is the energy of motion. So if an object is moving, it has kinetic energy, whereas potential energy is the energy of position or stored energy. So the higher that you are, the more potential energy you have. So this is when you're higher up, and when you're at rest at the highest point, that's going to be the most potential energy. Okay. Electrical energy is the motion of electrical charges. So this is going to come from things like outlets, right? Outlets or electricity. All of those things have electrical energy. And then over here we have light energy. Light energy is the energy of light, of photons. So this could come from light bulbs or, for example, sunlight. Okay, so now that we have that background information, we should be able to do question number 16. So taking a look at question number 16, it says to identify the starting and ending energies in the following scenarios. So a motor gets plugged into an outlet. Think about the fact that this is going to be electricity, and then gets turned on and begins to spin. Think about how that is a type of motion. All right, so again, this is what we're starting with right here, the outlet, and ending with motion of spinning. Over here, a fan that uses batteries. All right, we just talked about the type of energy that batteries is on the previous slide, so if you need to, you can go back. But this is what we're starting with, okay? Is turned on so that it begins spinning. Again, that motion again is also, that spinning is also motion. So again, go back to the previous slide if you need to think about what type of energy we are ending with right here, okay? A solar cell uses sun to provide electricity to the city. Remember that sun, we just talked about the type of energy that comes from the sun. That's our starting. And again, if it's providing electricity to the city, what type of energy is that? That's our ending. And then in our final scenario, a ball is held at rest. That means that it is, and then dropped, right? So it's held at rest at a specific height. So think about the type of energy we just talked about. That's our starting energy. And then it gets dropped. So as it gets dropped, remember now it is in motion. And so think about what type of energy that is for our ending. All right, pause the video, continue playing when you're ready. Questions number 17 and 18 ask you to take a look at the number of pathways that you see in a circuit and to determine if something is a series circuit or a parallel circuit. These are just examples. Please don't copy these examples because yours will be different. Okay, so if you take a look here at this first example right here, we can see the number of pathways from the battery back to the battery, right? We're going to follow this along. So here's one pathway right here back to the battery, and I can also see a second one. So here's one pathway, and then again, if I go from starting, I can actually continue to follow this wire, go back here, and you will see that I end up with a second pathway right here. So in this case, there are two pathways, right? And so if there are two pathways from the start to the end of the battery, remember that anytime we have two pathways or multiple pathways, that makes something parallel, right? So that could be 2, 3, 4, right? Multiple pathways, 2, 3, 4, etc. make something a parallel circuit. Okay, now over here, let's go ahead and follow from the start to the end of our battery, right? So if I start at our battery, follow the wire around, There's no branches here, so I just go straight through these lights. And coming back here, again, the number of lights doesn't matter. There's still only one pathway I can take to get from start to end. So in this case, there's actually only one pathway, and that would make it series, right? So again, anytime, regardless of the number of lights, regardless of the number of lights or resistors, those are also called resistors, if there is only one pathway from start to end, that makes something a series circuit. All right, that should help you with questions 17 and 18. Pause the video and continue playing when you're ready. All right, question number 18 is taking a look at holiday lights. This is not the picture that you have, so please don't use this one, but this is going to be an example that will help us to better understand this. So again, this is an example. Do not copy. Okay, so taking a look here, is there one or multiple pathways? Taking a look, again, from start to end of our battery, right? Let me grab a different color here, right here. I can only go through one pathway, right? So I'm going from here to here, and again, back. Again, it doesn't matter the number of light bulbs. The fact is I can only go through here in one specific pathway. So if there's one specific pathway, remember that means that this is a series circuit, right? So this is an example of a series circuit, okay? And therefore, if one of the light bulbs goes out, remember that we talked about in series, if one light bulb goes out, it breaks the entire circuit, right? So if I have this light bulb go out, now the entire circuit is broken. So in series, one light bulb goes out, entire circuit is now broken, and therefore all other lights go out. Okay, so that's when we're talking about a series light bulb. Let's go ahead and talk a little bit about a parallel circuit. Okay, so here, is there one or multiple pathways? So taking a look, let's follow this along, right? So I can go from here to this first light and back to the battery, here to the second light and back to the battery, to the third light and back to the battery. So we can see that there are definitely multiple pathways here, and therefore this is a parallel circuit. And the nice thing about parallel circuits that we learned is that even if one light goes out, all of the other lights still have their pathways, right? So taking a look at this example, right, you can see that this light bulb has gone out, and that's understandable that this light won't work anymore, but all the other pathways still work, right? So we can still see that this pink light has a pathway, and this green light has a pathway. And so since all the other pathways are still unbroken, this means that none of the other lights go out, right? So since the other pathways are still not broken, none of the other light bulbs go out, right? So they all stay on, except for the broken light bulb. Okay, so that's talking about a parallel circuit. Now let's go ahead and take a look at the picture in your problem. So this is the actual picture in your problem, and this one actually has both series and parallel. The reason is because what you can see is that I can see a pathway going through these light bulbs right here. I can see another pathway going through these light bulbs right here, a third one right here, and a fourth one right here. Okay, so in this case, we do have 4 pathways, all right, but each of those pathways also has several lights on it, right? So what this means is that we do have 4 pathways, so those 4 pathways are in parallel to each other. However, in the individual row, they are in series with each other, right? So we can see that within a single row here, for example, this orange and this green are following the same circuit. So in that case, this orange and green one is in series. Okay, so what this means is that if we were to knock out one of the light bulbs, right? So imagine that here we're going to knock out this blue light bulb right here. Okay, if I knock out one light bulb here, this means that now this part is broken, right? So we can see that this row is now broken. Okay, so this row is now broken. And so all of those other light bulbs are definitely going to go out, right? So all of these other ones also go out, right? However, the rest of the rows are unbroken, right? So the rest of the rows will stay on because they are in parallel, right? So only the row in which that light bulb is in series will actually go out. Every other row will stay on because you can see here all these other rows still are unbroken. They have no breaks in their circuit, so those ones will stay on. This should help you with question number 18. Pause the video, continue playing when you're ready. All right, so question number 19 here. Apologies, this is actually question number 20. Sorry, this is question number 20. The previous one with this light bulb, it was 19. All right, so let's talk about question number 20 here. So question number 20 is just asking you to calculate the resistance of a series circuit. This is just an example, so again, please do not copy. Right, just an example, please do not copy. All right, but we did learn that in series, resistance just adds up together. So we learned an equation where the total resistance, RT, in series is just the addition of whatever your first resistor is, plus your second, plus your third, plus however many more resistors that you have. So taking a look at this example, right, that we did in class, we see one resistor that I can label as R1, has 5 ohms of resistance, R2 has 7 ohms, and R3 here has 3 ohms. So if I go ahead and I plug those in, right, we can plug in 5 ohms plus 7 ohms plus 3 ohms, and if I go ahead and I calculate that together, right, 5 plus 7 is going to give me 12, plus 3 more would give me 15 ohms as my final answer. Again, this is just an example, so do not copy this. However, for your units in question number 20, please write out OHMS as your units. So OHMS is the units for number 20, but again, do not copy the number because yours will be different. All right, so this should help you with question number 20. Pause the video, continue playing when you're ready. All right, so at this point you should be done with your exam. Again, I apologize, this is question number 20. This one was number 19. If you have any questions, please make sure that you reach out to your teachers, and I will talk to you later. Bye, everyone.